Good afternoon. Today we are going to see the maximum shear force and bending moment in gantry girder. So when we will solve the problem in gantry girder, we will directly write the values. Here I will explain in detail how we have to calculate these values. So now we have determined maximum shear force and bending moment. Maximum shear force and bending moment for a gantry girder of span for a gantry girder of span 8 meter. I have considered directly wheel load. Wheel load is 200 kilonewton. This is factoried again. Factoried. And wheelbase. And wheelbase is 3 meter. Self weight of gantry girder is self weight of gantry girder along with rail is 2 kilonewton per meter. And we are interested to solve this problem. Now we will go with step 1, given data. So we have step 1, given data. So we have given 200 kilonewton and along with this wheelbase is 3 meter. So we have 200 kilonewton and this is 3 meters. And the span of gantry girder, this is given as 8 meters. With 2 kilonewton per meter load. So this data is given. So we have 2 kilonewton per meter along with rail. And self weight of rail plus gantry girder. So this is given. And now we are interested with maximum shear force and maximum bending moment. Now we have step 2. Maximum shear force. Maximum shear force. We have condition. One of the wheel load on one of the support that is a reaction and other will be accordingly. Now we will go for this. So I will draw the diagram. So we have this as 8 meter. And UDL we have 2 kilonewton per meter. UDL 2 kilonewton per meter. We have one of the wheel. I will change the color. So we have one of the wheel. We are going to place on this reaction. So we have one that will be 200 kilonewton over here. And accordingly, we have other which is at 3 meter, again 200 kilonewton. And then we are interested to calculate value of R1, which will be my maximum shear force. So now we will take a moment about R20. Moment about R20, and we will get value R1 into 8 minus 200 into 8 minus 200 into 5 minus 2 into 8 into 4, which is equal to 0. And from this we will get value of R1, that is equal to 200 into 13 plus 64 divided by 8. It comes 333 kilonewtons. And we have therefore maximum shear force equal to maximum shear force equal to 333 kilonewtons. So this condition is important. One of the wheel load on one of the support. So we have put it on one support. So accordingly, second wheel load will be at 3 meter from the reaction. So accordingly, we have calculated, and maximum reaction will gives you maximum shear force. So now as the load is on R1, so definitely my R1 reaction will be maximum, and accordingly we are going to get maximum shear force equal to maximum reaction, that is equal to 333 kilonewton. Then we have step 3, maximum bending moment. Step 3, maximum bending moment. Maximum bending moment. Now condition for this, we have one of the wheel and CG of wheel and CG of which should be equidistant from center of span. From center of span. So accordingly, we have to put it. So we have 8 meters. We have 2 kilonewton per meter. So we have this as 2 kilonewton per meter. And now try to understand how we have to place it. Now I will draw this. We have this wheelbase. We have this as 200 kilonewtons. We have this 200 kilonewtons. This is 3 meter. Our load, that is a resultant of this. So CG means resultant. which is 400 kilonewton, will act at 1.5 meter from both. Now we have to put it in this fashion that this 0.75 meters, this also 0.75 meters. So this I will mention as C. So here we have C. This C we have to place on C. And then what will happen in that case? So your one of the wheel will be at 0.75. So I will plot here. So this is my one of the wheel, 200 kilonewton. Then at the center we have again 0.75, which is 400 kilonewton. Distance between these two is 1.5 meter. This is 0.75. This also 0.75. And the second wheel load we have again at 1.5 meter. Try to understand clearly. I have dotted, shown this dotted. And we are interested to find now reaction and maximum bending moment. So what I will make it, I will put only resultant and replace other load so that you will understand exactly what we have to go for. So we have this as 2 kilonewton per meter. And then your load is at 0.75. I am again making it dotted. So 0.75 from center, and this load we have 400 kilonewton, and from center it is 0.75, and this distance is 4 meters. Again this is 4 meters. And then I will find reaction R1. This is R2. So we will have moment about R2 is equal to 0. This is R1, this is R2 now. And then we will get it as R1 into 8, R1 into 8 minus 400 into 4 minus 0.75 minus 2 into 8 into 4, which is equal to 0. And if we will calculate this value of R1, then we are going to get it as so divided by 8. So this reaction comes 170.5 kilonewton. We have to find maximum bending moment under that wheel load, which is equidistant. So now I will consider only that part. So now we have this again 2 kilonewton per meter. And then we have that one of the wheel load that is at equidistance. So we have this as 4 meter. And then other also we have 4 meters. And then we have to show that one of the wheel which is equidistant from the center, and that I will plot over here, which is 200 kilonewton. And we have this distance as 0.75 meters. And then now we have to take moment under this load. So this reaction is 170.5 kilonewtons. And now we will find maximum bending moment. So we have maximum bending moment equal to under the load, under the wheel load, and that is equal to 170.5 into 4 minus 0.75 minus 2 into, so this distance we have 4 minus 0.75 is 3.25. So minus 2 into 3.25 square by 2. And then we will get this value that is equal to 543.56 kilonewton meter. So this is my maximum bending moment, and this we have to use for design this section. So when we will solve this problem, we will directly go for values. We will not explain in detail for this. Therefore, this video is prepared over here. So now we will stop here only. Thank you.